it says write the polynomial function in standard form. We've done that a million times this year. You do a bunch of distributing. Identify the zeros and the x-intercepts, and it gives us a nice little function. So we have the function f of x equals x plus 2, and then we have x minus I root 3, x plus I root 3. So what we see here, which we haven't done a ton of, we've done distributing. We haven't done a ton with imaginary numbers, so I just wanted to kind of throw this one in to remind ourselves of the steps, but just so we know what to do with imaginary numbers as well. So if it did ask for the zeros, I'll just do those quick off to the side. The zeros are at -2, I root 3, and negative I root 3. And just as a reminder, when you have an imaginary or a complex root, you also have its conjugate. So those two have to go together. If you have one, you automatically have the other.
Mrs. Sherman, that's example 2.
Oh my God, where is it? What?
Yeah.
What?
It's example 2.
Oh my God, do I have a different, my answer key is like totally different than yours. Let me see where. What's example 1? Why is this weird? Okay, do example 2. Okay, I don't know why my answer key is different than yours. It must have just been like a different version. Sorry, example 2, guys, sorry about that. It really does say example 1 on mine. I must have just had a different version. Okay, anyways, let's just get going with this. So what I'm going to do is I'm going to focus on these two binomials first. I'm going to distribute those, and then once those are distributed, I can go back to the x plus 2. So as I distribute, we get x squared, and then we would get plus, I'm just going to write it as xi root 3, or you can write it as ix root 3. It's just kind of weird looking, but that's okay. We'll just kind of write it. And then we have minus xi root 3. And once, it should always happen that those are going to cancel. That's why we have conjugates. They cancel that middle term. And then just be careful with this last term. Okay, so there's going to be a minus sign. I times I is I squared. Root 3 times root 3 is just 3. So I'm going to throw that 3 in front. Whenever you multiply a radical by itself, you're just left with a number underneath. So the magical, this cancels, and we're left with x squared. Remember, I squared is -1, and 2 negatives make a plus 3. Oh, that's kind of beautiful once you do it out. And then remember, now we're going to multiply that by x plus 2, and see what we get. So when we distribute, I'd get x cubed plus 3x plus 2x squared plus 6. I am going to put that in standard form. I'll word it as f of x, sorry, f of x equals. And that would be your polynomial equation in standard form. So stuff that we've done. So I thought, it's good to remind ourselves of things. If it says write something in standard form and it gave it to us in factored form, we're just going to distribute. Just be careful, with the little intricacies of having i's and radicals and all that fun stuff. Once again, when you have an imaginary root, you also need its conjugate, which was kind of given to us. So that's kind of, all right, well now I need to look at this because my numbers are off. So maybe we're not doing 1, 2, we're doing 2. Let's see. Goodness gracious. I guess, I don't want that one. Oh wait, no, I do want that one. Okay, 3. Oh, your 3 is my 2. Okay, so number 3 is going to be the next one. So we're doing 1, 2, for you guys, 2, 3. No, I'll pick up the other ones in a second. Silly me. Are there any questions with that one? So just bringing in stuff we've been doing, just reminding ourselves, it's a Monday morning or Monday afternoon, whatever it is. All right, so this one, write a polynomial function of minimum degree in standard form, good old standard form, with real coefficients whose 0 includes the following. So we have zeros, this is example 3 for you guys. at -3, 4, and 2 minus I. So just as a reminder, we technically have 4 zeros, only though, did I just totally write that wrong? That should be 2 minus I, sorry, I say things and I write different things, there we go. So we have a 0 at x equals -3, at x equals 4, and then just as a reminder, if you have 2 minus I, you also have a 0 at 2 plus I. So just make sure you remember that part. When you see that I, you also need to include its conjugate as one of the zeros. So although it only gave us 3 zeros, there's technically 4. So at minimum, this is a 4th degree polynomial. This is where it gets funky. This was like 9 something. The one that was weird, the last one on number 9 in your problem set. So let's start right, oh yeah, oh my God. Man, okay, I'm just gonna give up on this answer key. It's doing me wrong. Okay, the 4 is negative, thank you. I'm just not gonna look at the answer key anymore because the answer key is just a little bit different or enough difference that it's just annoying. Okay. So let's write it in factor form. We would write that as x plus 3, x plus 4. Here's where you need to be careful. It's x minus my 0. My 0 is 2 minus I. So I'll rewrite that in a second. Just as a reminder, it's x and the opposite, so minus 2 minus I. And then x minus 2 plus I. That's the place that like maybe it was a little confusing. But since you just have, you have a 2 and a 2, you start with that. So it's x minus binomial and x minus the other binomial. So I'm just going to rewrite those as x minus 2 plus I and x minus 2 minus I. First two stay the same. Now we have a whole lot of distributing to do, so this is going to be fun. I'm going to start, it doesn't really matter where you start, I guess. I'll just start with 2 at a time. So let's do these 2. I'll start with those 2, those are nice. Good old distributing, just standard here, x squared. That will give me plus 4 plus 3, so that's plus 7x plus 12. I'm just going to keep that in parentheses just to keep it together. Now let's do the same thing for those other, but those are trinomials, so just be careful. It just ends up being a lot of things, so you don't want to get messed up. So I'm going to start over here. Let's see what we get. I literally, like, especially here, I need to stay organized. So I'm going to start with this first term and distribute it. So x times x is x squared. And then we would get minus 2x minus ix, or you can write xi. It doesn't matter. Just choose a thing. All right, now we have the second term we have to distribute. Minus 2x. That would give me plus 4 plus 2i. Okay, whew, this is a lot of stuff. And one last thing to distribute the I. So we get plus ix minus 2i. You're going to see there's a lot of things canceling in a second. And then minus I squared. Ooh. So let's see what the heck we're left with. We have x squared. I have an x here and x here. I don't want that one to the I, so we'll do that. Okay. Negative 2 minus 2 is negative 4x. So then we'll see negative ix plus ix, those cancel. Let me just deal with this. The plus 2i and the minus 2i cancel. So what should always end up canceling is your imaginary parts. You shouldn't really have those in your standard form. So that's why we can do this whole thing. It cancels them out. And then last but not least, I have this 4. And remember, I have minus I squared, which is really minus -1, which is really +1. So 4 plus 1 is 5. Whew, that took a little bit of work. And of course, we're still not done. I'm gonna make it that easy on you. So now we need to distribute that. Oh, goodness gracious. But we can do it. I know I'm kind of running out of room and, oh, I got some room on my right side here, so I'll do it over there. Right below. All right, so let's start. Trinomial times trinomial. One term at a time. X to the 4th. Then if I do it times that, that would be minus 4x to the 3rd. I'm just doing one thing at a time. It's all stuff we know how to do. There's just a lot of it. Plus 5x squared. Okay. Second term. Plus 7x cubed. Then what will I get? Minus 28x squared. Plus 35x. And then what do we got? The 12 to distribute. Plus 12x squared. Minus 48x. Plus 60. And last but not least, let's combine like terms. We have x to the 4th. Where do we go? We have a cubic. -4 plus 7 is plus 3x to the 3rd. Quadratic. What do we get? 5 minus 28 is -23. Plus 12 is -11. Let me tell you something wrong. My brain's kind of fried today. 35 minus 48 is -13. Plus 60. Oh, what a joy that was. Now, would we ever give you a lot of those? No, I don't even think there's one of those actually on me. Open note quiz at least. But it is something that might pop up. So if we give you zeros, we can write it in factor form. The big thing, you know, if you have a 0 of -3, that's x plus 3, and -4 is x plus 4. When you see that imaginary root, you need to put the conjugate as well. So that's the first I did, just remind myself I need those two now. And then just the big thing was kind of rewriting it in the factor form. So it's x minus my binomial, and then x minus my binomial. You have to distribute it, and you distribute 8 million times for that problem. But in the end, you get your beautiful answer, and there you are. Whew. Okay, let me look. There's no one out of order. Does anyone have a question on that one? Other than it just being like annoyingly long with the distributing. It's stuff we've done. It's just I wanted to point out those imaginary roots. All right, we only have 2 more, guys. So I was going to do number 4 here. Is number 5. So we're going to do number 5. Sorry, I don't know my mind is numbered differently. And then after that, let me just organize myself now on here. We're also going to do number. We're also going to do number 6 after. So those are the 2 that we're going to finish up with. All right, beauty. So number 5, find all of the zeros of, and it gives us a nice little polynomial function, and factor over the set of complex numbers. Okay, so we basically need to just find the zeros, and we also have to put it in factor form, so that's all that means. So just make sure you understand what comes of that. Once again, we're going in blind. I have no clue what the factors are, so we are always going to use the rational root theorem. We should be getting very comfortable with it because I feel like we've done a million rational root theorems over the past week. So this is number 5. So there's a few more of these in here. Once again, we're just picking 1 or 2 just to kind of get our practice in. And let's see what we get. So I have no clue what we get. So let me write my function. Once again, you have a quintic here, so that makes it a little more complicated. Oh my gosh, this baby's long. Okay. So you kind of start, once again, we have no clue what the factors are. So rational root theorem, what are the factors of the constant? Okay, 8's not too bad. Plus or minus 1, 2, 4, and 8. And then thankfully the leading coefficient is just plus or minus 1. I always love when that happens. It's like, oh, thank you, Lord. So the possible rational roots is basically, we say P over Q, just constant over coefficient. If I took all of those and divided it by 1, it kind of just gives me that list back out. All right. So we say, okay, well, if those are our possible ones, how do I figure out one? I just grabbed my calculator, because I'm going to be honest, I have no clue. So we're just going to kind of plug in and see what works. And we know that it works if when I plug it in is I get a 0. So we call it the remainder theorem. That means it is a factor. So I usually just start with 1. Okay, so let's try f of 1 and see what we get. I have no clue. So 1 to the 5th minus 3 times 1 to the 4th. This is just going to plug it in.
With DJ overall, please report to the middle school main office. DJ overall.
We're like losing a lot of people today. I don't know. Oh, and is there anything more delightful than just plugging the first one in and you get a 0? Nothing better. So yay. So we know 1 is a factor. So now we need to find the other factors. And the way we do that is once you have the first factor, you can use synthetic division. That's way easier than plugging each of those in and all the negatives. It's a big pain in the butt. So if we are dividing by 1, I grab my coefficients. And I just see what magically happens here. I like synthetic division, it's quick. 1 is negative 2. Negative 2. Sorry, couldn't remember what my actual answer was. Negative 7. Negative 7 is negative 2. Is negative 2. Is negative 8. Is negative 8 is 0. Okay. You should have a remainder of 0 because we just found that that was a factor. So then we say, well, okay, that's exciting. But now I have, what? This would be 1x to the 4th minus 2x cubed minus 7x squared minus 2x minus 8. How the heck am I supposed to find a factor of that? Hey, guys, what should we do? If you don't know a factor, you should always do the rational root theorem. I know it hurts. It hurts your little souls. But we do the rational root theorem again. So if you're ever stuck, like you're saying, I don't know what that is in fact. Like I can't factor that right now. You do the rational root theorem again. The nice thing is the numbers were the same, right? So these are my same possible roots. So let's just plug them into there and see what we get. If I do here, what do I get? I already did 1, so 1's out. You can try negative 1. I'll try 2, I guess. Once again, you're kind of just going in blind on these bad boys. 2 is out. Let's try 4. Once again, once you like put it in, you should be able to just kind of throw it back in your calculator. Oh, 4 works. Okay. So that part should be quick. Once again, the first time you input it, you should be able to kind of reuse that input. Just put some different numbers in. But at this point, I did plug 4 in. It is a factor. Okay. Just trying to explain what I did. So now let's do synthetic division again. Let's see what we get, guys. Synthetic division with this polynomial. 1, negative 2, negative 7, negative 2, negative 8. Boop. I was like this part. Is 8 is 1 is 4 is 2 is 8 is 0. So that gives me what? X to the third plus 2x squared plus 1x plus 2. So you could do two things at this point. You could do rational root theorem again, because what'll happen, I could just, because you would just have 1 and 1 and 2 and 1. There's not actually that many options, so it wouldn't be bad. Or if you notice it's factorable, you can do that. This is actually, I can factor this by grouping, so I'm just going to group it. Why not? But if it wasn't factored by grouping, you would just do the same process over. If you don't know the roots, you just do rational root theorem. Once again, for that second one, technically their GCF is just 1. So you just, reminder to write that. That factors, that should be x squared. That factors to x squared plus 1, x plus 2. And now we can finally solve for the rest of our factors here. Okay, so in a second I'm just going to organize my information. But when I did that, I solved one using square roots and then one was just a linear factor. What's going on in here? Let's make sure we actually answer the question. So sometimes I think we just like start circling somewhere like, yeah, we got it. You can't just spread everything out and just assume like, yeah, we'll find it. Like, you know, Mr. Sherman's gonna take a year to find where everything is. So organize your answer. The question was, find all of the zeros. Oh, was that it? Or did it say something? Find all the zeros and factor. So we have to list the zeros and we have to list it in factor form. So I would say the zeros are, what do I have? 1, 4, -2, I and -I. And once again, that's what the fundamental theorem of algebra says. It says, if this is a 5th degree polynomial, there are 5 roots. So just make sure you have 5 roots. And then it says also factor. So in factor form, I just kind of base it off these zeros. It would be x minus 1, x minus 4, x plus 2, x minus I, x plus I. Okay. Beauty. I don't think there's any that, you have to keep doing the rational root theorem a million times, but it's good just to remind you. If you're ever stuck and you don't know a factor, use the rational root theorem. Mr. Berry's dancing. All right, so that was a little bit more. There is one more problem I want to show you. I'll give you a hint. This next one, number 6, there is one like this similar on your open note quiz. So just as a heads up, when it's open notes and it tell you, so I'm like, make a note for yourself. So it gives us a complex number, 2i, and it tells us that 2i is a 0 of this polynomial. Okay, that's exciting. We want to find the remaining zeros and factor. So once again, at the end, we'll list what are the zeros, what's the factor form, over the complex numbers. Okay. So as I'm looking at 6, I'm just going to start organizing myself. The first, before I start, were there any questions on that? Yeah.
When it says like factor, you write it in factor.
You just write it in factor form. That's it. Yep. So that's just more introduction. Okay. So number 6, and then this is our last one. I feel like it's always nice on Thursdays and Fridays, and Monday, Tuesdays is always crappy. So I'm glad we get to go outside. This cold. Okay. So the big thing for this one. Sorry, everything. Okay. It tells us that 2i is a 0. Okay, that's exciting. And we have this polynomial, this function, whatever you want to call it, 2x the main thing you want to take away from this is if 2i is a 0, then you also know that negative 2i is a 0. That's the big thing you want to take from this, the conjugate theorem. If you see or if you're told that one of your zeros is imaginary, then you automatically have to put a conjugate. Hello? That's okay. I do. All right, thank you. Bye. Go ahead, Jesse. So, we're just gonna start like we normally start. If I tell you a 0, we can divide it out. So let's use synthetic division. We had done one like this the other day in your packet. And we're gonna divide out 2i from my original polynomial. Always, just as a reminder, when you're doing synthetic division, make sure you don't have any breaks, right? So 4, 3, 2, 1, none. Okay, we're good. You don't have to throw zeros in anywhere. So let's start. Bring this down, you get 2. When I do my multiplication, that gives me 4i. And I can't, there's a real part, there's an imaginary part, so we leave it as a complex number. 1 plus 4i. Then we're gonna kind of zigzag down. You just have to multiply this by both of those. So 2i times 1 is 2i. And 2i times 4i is 8i squared, which would just be negative 8. So I tend to always write it kind of in that order with a real and imaginary. If you flip it, it's fine. You're going to get the same answer. I just like to keep things the same. Once again, 2i times 1 is 2i, and then you just multiply it by the 4i. 2i times 4i gives me 8i squared, and the I squared turns into a negative. That's where the negative 8 comes from. So negative 7 minus 8 is negative 15 plus 2i, right? Once again, you can combine the real parts, but the imaginary part is just kind of chilling. All right, let's see what we get. 2i times negative 15 is negative 30i. 2i times 2i is 4i squared, which is negative 4. Okay. Oh, well, 4 plus negative 4 is 0, so those kind of cancel, and I'm just left with negative 30i. And then last but not least, 2i times negative 30i would give me negative 60i squared, but the I squared is also negative, so that would turn to positive 60 with a remainder of 0. You always know, like once you get the remainder 0, you're like, okay, I know it looks weird, but I know I'm right. Because since that was a factor, the remainder should be 0. So we're in good shape there. And then you're saying, that's not my answer. That's just plain old ugly. But if 2i was a 0, then negative 2i is also a 0. So I'm going to take these that I just found and divide it by negative 2i. And that's going to be all sorts of beautiful, and then we'll be done. So let's bring it down. Bring that down. You get 2. Multiply that times that, you get negative 4i. Magical, that cancels, I'm left with 1. That times that is negative 2i. You're kind of seeing what's happening. That cancels, you're left with negative 15. And that times that is 30i, because we would have a remainder of 0 since that was a factor. And then we can just bring back 2x squared plus 1x minus 15. Now it's asking us, find the factor, find the zeros, write it in factor form. Hey, we can factor this, I think, right? So if you see something's factor, we'll go for it at that point. What do I need? 5 and 3. So that would be 5 and 3. I want positive 6, negative 5. All right, so I'm just going to reorganize my answer here, because once again, this happened on the last quiz. You kind of like wrote some stuff, but you didn't write everything. So make sure you organize your answer, because we have everything we need now. My zeros are at 2i, negative 2i, And I can find the zeros quick from these. These are just linear factors. 5/2 and -3. Just do a quick check. This was a 4th degree polynomial. I should have 4 answers. That's all the fundamental of algebra, the fundamental theory of algebra says. Whatever your degree is how many roots you should have. And if you want it in factor form, it would be x minus 2i, x plus 2i, x, or I'm not gonna write it as x minus 5/2. That's ugly. That would be 2x minus 5, right? If you wrote x minus 5/2, I guess I'd give it to you, but it'd just be a little bit more thing. And x plus 3. And that's the 2 things it asked me for, so that's how I write my beauteous answer. One other thing you technically could do, since we know that 2i and -2i were the roots, you could have said, you could have started with x minus 2i, x plus 2i. And if you multiply that out, you get x squared minus 2i minus 4i squared. So it ends up being x squared plus 4. So if you wanted to do that, then you could do long division with that and that. I know a lot of people just don't like long division, so I like to do it in 2 steps. But if that's something you wanted to do, you could take the 2 original factors that you knew, because they're conjugates. You can multiply them out and find your polynomial that it comes out to. And then if you wanted to do long division with the original polynomial, you'll get the same answer. So that's just a preference thing. I'm always keen on synthetic division as opposed to long division. So what happens, obviously we didn't do every problem, that's okay. So I'll put my answer key up, the numbers around, but what are you gonna do? So if you want an extra practice, or if you just want to try another one, the other ones are similar. There's some on the back, like we did this stuff forever ago, so I'm not even really going over it. It's sketching a graph, like we've done sketching a graph since like the first day of polynomials. So it's just if you're given zeros with different multiplicities, what it will look like. So I'm not even going over, I don't even think that's on here actually.